precision work.
Back it up. These are all halves. Oh, yeah, there goes that one pop.
So how does the engineer come up with these solutions? That's what we think of as the design process. The design process is actually much broader than that, but that step where you're coming up with creative solutions is, I think, what makes engineering really fun, because there's no mathematical formula that's going to tell you how to design a product. For instance, pencil sharpener, we see this as, well, of course, this is the way a pencil sharpener is designed. But everything about the pencil sharpener was a conscious decision made by an engineer. There's no mathematical formula that tells you this is the optimal pencil sharpener. It may be or it may not be. It could be. It could examine this more fully and find out there's better solutions. In fact, not everybody would agree that this is the best pencil sharpener for their uses. Some would prefer an electrical pencil sharpener. Some would prefer one that's smaller, that they can hold in their hand. And so we have a variety of pencil sharpeners that meet different needs. And when you're coming up with these solutions, what you're trying to do is brainstorm a lot of different possibilities. And at the beginning of the design process, you want to increase the solution space. You don't want to start with certain assumptions and box yourself in.
Right here.
So you want to think very broadly. You want to think of lots of crazy ideas, because sometimes the crazy ideas, even though they're not feasible, may lead to feasible solutions that can be useful. So once you've come up with lots and lots of ideas, you winnow them down into the feasible ones, and you flesh them out in greater and greater detail until you hopefully have 3 or 4 or 5 solutions that you think are pretty darn good. And then it comes time to decide which one of these solutions is the best, and that's where the criteria comes in. You can then look at those solutions and evaluate each one of those solutions based upon the criteria, and whichever one gets the best score, that's the one that the engineer would go with, or the engineering team would go with. Things that we find that are most important for student success are whether students are organized, disciplined, and especially tenacious, because students are going to run into problems. They're going to do poorly on exams. They're going to have trouble with lab assignments, and it's those students that say, okay, I didn't do so well on this, but I'm going to pick myself back up and I'm going to go at it again. The ones that are tenacious are the ones that tend to succeed.